In this video, we're going to look at a couple of more examples, how to evaluate indefinite integrals and definite integrals using a technique called U-Substitution. So the first example is to evaluate, find antiderivative of x times the square root of 3x squared plus 1 dx. And the second example, part B, is to evaluate a definite integral. So this will be, the answer will be a number from integral from 0 to 1 of x square root of 3x squared plus 1 dx. Okay, so we'll start with part 1, and we're going to use the U-substitution. So the integral of x times the square root of 3x squared plus 1. First, we want to rewrite this in a slightly different way. We'll put the square root first. So square root of 3x squared plus 1, and then times x dx. Remember, the rule for U substitution is to let U equal to whatever the expression is inside the parentheses or a radical. So in this case, U is equal to 3x squared plus 1 du. Differential is 6x dx. 1 6 du is x dx. Going back to the integral, there's our u, and x dx is 1 6 du. And we're going to rewrite that as the integral of square root of u times 1 6 du, or 1 6 times the integral of u to the 1/2 du, which is a basic integral that we only will use power rule of anti-differentiation. So this is 1 6 u to the 3/2 over 3/2 plus c, or we can rewrite this as 1 6 times 2/3 u to the 3/2 plus c. And let's finish this up. We want the answer back in variable x. So 1 6 times 2/3 is 2 over 18. 2 over 18 u to the 3/2 plus c, or 1/9 u to the 3/2 plus c. And now we just want to return the answer in variable x. So the original integral of x times square root of 3x squared plus 1 dx is now equal to 1/9. Remember, u was 3x squared plus 1, so 3x squared plus 1 to the 3/2 power plus c. And that's the answer to part A. Now we go to part B. Here we want to evaluate the definite integral from 0 to 1, x square root 3x squared plus 1 dx. So by fundamental theorem of calculus, we need an antiderivative, which is 1/9 3x squared plus 1 to the 3/2. We evaluate that antiderivative from 0 to 1, which is equal to 1/9. And now let's plug in 1 for x, so that's 3 plus 1, which is 4 to the 3/2 power. And when we plug in 0 for x, we have 1 to the 3/2 power. And so this is equal to 1/9 times 4 to the 3/2 is 8. So 8 minus 1, and the answer is 7/9. Here we want to use also, want to show the second method of U substitution in solving definite integrals. So we'll go back to the U substitution solution, the integral from 0 to 1 of x square root of 3x squared plus 1 dx. We're going to let u equal to 3x squared plus 1. Just like before, the differential du is 6x dx, or 1/6 du equals to x dx. And now we need to notice that when x is 0 and u is equal to 3x plus 1, u is going to be 1. And when x is 1 and u is 3x squared plus 1, u is going to be 4. That means that the integral from 0 to 1 of x square root of 3x squared plus 1 dx is equal to the integral from 1 to 4, and the 1/6 is in the front, of u to the 1/2 du. And so this way we will never have to go back to x to evaluate the integral. This is 1/6 u to the 3/2 over 3/2 minus, or evaluated from 1 to 4, and we can rewrite that as 1/6 times 2/3 times u to the 3/2 evaluated from 1 to 4. And this is 2 over 18, or 1/9 u to the 3/2 evaluated from 1 to 4, which is 1/9 times 4 to the 3/2 minus 1 to the 3/2. Again, 4 to the 3/2 is 8, so it's 1/9 times 8 minus 1, which is equal to, just like when we went back to x to evaluate the definite integral, the answer is 7/9.